Good morning. Today we are going to discuss the subject Information System Security, and the algorithm we are going to discuss is DES, which is Data Encryption Standard Algorithm for BTech CSE students 6M. My name is Megha Garg. So let us start with the DES algorithm. DES algorithm is actually DES algorithm has been found vulnerable against very powerful attacks, and therefore the popularity of DES has been found slightly on decline. DES is a block cipher algorithm, that is, the bits are not encrypted singly one by one. Instead, they are encrypted as a complete block, and the block is of size 64 bits. That means 64 bits of plain text are given as input to DES. The DES has a 56-bit key, and which converts the given plain text to 64 bits of cipher text. So this is how the algorithm goes. We have mentioned that DES uses a 64-bit key, but what really happens is that initially 64 bits of initial key is given, and it is converted to 56 bits by removing the bit position 8, 16, 24, 32, 40, 48, 56 and 64. Thus, every 8 bit is discarded from the 64-bit original key to produce a 56-bit key, like this is shown. The 8-bit is discarded, the 16-bit is discarded, 24-bit is discarded, 32-bit is discarded, 40, 48, 56 and 64th bit are discarded. Then what happens is DES algorithm uses two technologies, two fundamental attributes, which is substitution and transposition. So substitution is also known as confusion, and transposition is also known as diffusion. So DES consists of 16 steps, and each step is known as a round. Each round performs substitution as well as transposition. So in first step, what happens is 64-bit plain text is handed over to an initial permutation function. The initial permutation is performed on plain text. After initial permutation steps, the permuted blocks is produced into two halves, that is the left plain text and the right plain text. Now each left plain text and right plain text go through 16 round of encryption process. In the end, LPT and RPT are rejoined and a final permutation is performed on the combined block. And the result of this block produces the 64-bit ciphertext. So this is the diagram given. We have 16-bit plain text. Initial permutation performed gives us LPT, which is the left plain text, and RPT, right plain text. On each of them, a 16 round is performed using a key. After that, final permutation is performed and we get the 64-bit ciphertext. So how is the initial permutation done? As we have noted, the initial permutation happens only once, and it happens before the first round. It suggests how the transposition in IP should proceed as shown in figure. For example, it says that the IP replaces the first bit of the original plain text with the 58th bit of the original plain text, the second bit with the 50th, and so on. This is nothing but changing on the bit positions of the original plain text, and the same rule applies to the bit positions. As we have noted that after IP is done, the resulting 64-bit permuted text block is again divided into two half blocks, each half block of 32 bits each, and each of the 16 rounds in turn consist of the broad steps outlined in the figure next shown. So after we have noted IP is done, the resulting 64-bit permuted text block is divided into two halves. Each half consists of 32 bits, and each of the 16 rounds in turn consists of the broad level steps outlined in the figure. We have key transformation, expansion permutation, S-box permutation, P-box permutation, XOR and swap. So what is the key transformation? We have noticed the initial key is converted to 56-bit key by discarding the 8-bit, and after that what happens is from this 56-bit key, a 48-bit subkey is generated during each round using a process called key transformation. So for this, what happens is 56-bit key is divided into two halves, each of 28 bits. These halves are circularly shifted left by 1 or 2 positions depending on the round. For example, in the round number 1, 2, 9 or 16, the shift is done by only position. For other rounds, the circular shift is done by 2 positions. The number of key bits shifted per round is shown in the figure. After an appropriate shift, 48 of the 56 bits are selected. For instance, after the shift, bit number 14 moves on to the first position, 17 to second. If we observe the table carefully, we will realize that it contains only 48 positions. Bit number 18 is discarded, like 7 others, to reduce the 56-bit key to a 48-bit key. Since the key transformation procedure involves permutation and selection, it is known as compression permutation. Because of this compression permutation technique, what happens is a different subset of key bits is used in each round. That makes DES difficult to crack. Now the next step 2, is the expansion permutation. So after initial permutation, we have 32-bit left plain text and right plain text. During the expansion permutation, the RPT is expanded from 32 to 48 bits. Bits are permuted as well, hence it is known as expansion permutation. This happens as the 32-bit RPT is divided into 8 blocks, which each block consisting of 4 blocks. Then each 4-bit block of the previous step is then expanded to a corresponding 6-bit block, that is 4-bit block. 2 more bits are added. The process results into expansion as well as permutation of the input bit while creating output. Key transformation process compresses the 56-bit key to 48-bit key. Then the expansion permutation process expands the 32-bit RPT to 48 bits. Now 48-bit key XORed with the 48-bit RPT, and resulting output is given to next step, which is the Xbox substitution. So thanks. This is all about your DES algorithm, and the next we will see some other algorithm.